Okay, here we go. All right, so in our new packet, we're on page 1, and there's a couple things that we're going to do. We're going to be talking about linear regressions. Okay, that's what this chapter is about, is lines and the data that follows the pattern of a line. So there's a couple of specific things that we have to handle in this class a little bit more in detail than what you've done in the past. So one is we want to make sure that we interpret the slope and we interpret the y-intercept. So when we have an equation like this, the equation of the least squares regression line, for example, this one says the percent that are on time, okay, is 87.2 minus 2.15 times the mishandled baggage. So before we get started here, let's kind of, I guess, keep in mind what is our explanatory variable. Explanatory variable. Okay, so the two different options are going to be explanatory variable versus response variable. Okay, so which one of your x or your y is going to be one's explaining and then one is the response. So which one explains? The x variable, good. So the x variable is explaining, so in that case our mishandled baggage is explaining the percent on time that we are, the predicted percent on time. Okay, now this symbol right here, this little symbol above the y variable, which is the response, is called a prediction hat. I call it prediction hat. This little thing here on top indicates that we are predicting the percent on time that you're going to be based on how much mishandled baggage there is. Okay, so how much mishandled baggage there is going to, based on that, we're going to predict the percent on time that the plane is, or the percent of planes that are on time in that day or whatever. Okay, so in this case, that's what we're going with. And so let's go ahead and think about interpreting the slope for this. So what is the value of the slope for this problem number 1? Good, negative 2.15. Okay. All right, so we have a little phrase, and then we'll put a song to it as well to help you remember this phrase. So the interpreting the slope says that for every one increase in the x, so in this case, for every additional mishandled piece of baggage, for every one increase in the mishandled baggage, the predicted, because see that's what this is over here, this prediction hat right here, the predicted percent of planes that are on time or whatever goes down 2.15. And I said it goes down because it is a negative slope. Okay, good. So let's write that down and exactly like that, and then we're going to talk kind of the song of it to help you with that. So for every one increase in the x, which is the mishandled bags, so for every one increase in the mishandled bags, you could also said for every additional mishandled bag, okay? And if you do not use the word predicted, it's wrong. The predicted percent of planes that are on time, so, because I'm just making it up that it's planes, percent whatever on time, the predicted percent on time, and because it's negative, it is decreasing 2.15. whatever units it is. Okay, so that slope is negative 2.15. That might help you. It should be similar to that. It's not word for word exactly that. Yeah, you could go down, you could put goes down 2.15. Yep, instead of decreases. Okay, so here comes the song that goes with that. Okay. Interpret the slope. 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 For every one increase in the x, the predicted y, it does this. Interpret the slope. 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 For every one increase in the x, the predicted y, it does this. Interpret the slope. 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 Okay, so that's your interpret the slope. And so if you know that song, then that's going to help you remember the words. Okay. Now, next thing we're going to do is interpret the y-intercept. Interpret the y-intercept. So in this problem, what is the value of the y-intercept? Okay. 87.2. Well, so the phrase up here, okay, so think about where the y-intercept is, okay? Let's think of a graph here. The y-intercept is occurring here on the y-axis when the x value is 0. Okay? The y-intercept occurs when the x value is 0. So look at this phrase. Interpret the y-intercept when x is 0. The predicted y is this. Okay? Now, we're going to keep in mind that in a lot of times the y-intercept is far away from the rest of our information and it doesn't make sense. So I think in this case on this problem it does make sense, but we'll talk about it in other problems. So look here on this one. Interpret the y-intercept. So when the x is 0, what does that mean in this problem with the context? Yeah, when there are no mishandled bags. See, that's the x being 0. When there are no mishandled bags, the predicted percent of planes on time, or whatever, is 87.2. I think that sounds reasonable in this case. Okay, so that's interesting. In this problem, the y-intercept does make sense. But I have seen lots of problems where you'll have a negative y-intercept or something and say it's about volume or the height of a tree or that kind of thing, and you can't have a negative height or a negative volume. And so a lot of times I've seen it where the y-intercept does not make sense. Now, here comes the song that goes to interpret the y-intercept. Interpret the y-intercept. It happens when the x is 0. The predicted y is this. And it often does not make sense. Interpret the y-intercept. It happens when the x is 0. The predicted y is this. And it often does not make sense. Okay. All right, there you go. So there's you a song that we can help us remember. When the x is 0, when there's no mishandled baggage. Okay. So let's now See if you can try this. Our next problem is about, what's this problem about? A year and the length of something. So maybe we got some tree that's growing or something. I don't know. Oh, I don't know. It looks like, yeah, it's decreasing. So maybe it's like erosion of something. I don't know. Okay. Or the tree is dying. What? Number of terrorists? Oh, I think that would be increasing probably also. Okay. So, first of all, what is the slope here? Okay, negative 1.375. Okay, so I want you to interpret the slope. Interpret the slope. Interpret the slope. Interpret the slope. For every one increase in the what? Okay, for every increase of 1 year, or you could say for every additional year. I think that makes sense in real world. For every additional year, okay, for every one increase in the year, the predicted, what, in this case, length does what? Goes down 1.375, and we don't know what the units, but the predicted length goes down 1.375 units, whatever that is. Okay? For every one increase in the year, the predicted length goes down 1.375 units. Okay, how about this one? Interpret the y-intercept. What? It happens when the x is 0. The predicted y is this. So what is y-intercept here? 64, 68. So, how is it saying? When the intercept, it happened in the x is 0. So what it means? When the year is 0. Okay, so that's a little strange. We don't have the context of this problem, so probably this problem would have been something like x is the years past 1980, or something like that. And then we would know if x is 0, then we're talking that we're at 1980. Okay, something like that. So when the year is 0, when the predicted y, the predicted what? Is that what it is? Oh, length. The predicted length is 6460 units. So at the start of whenever we're doing this, whatever year it is, at the start of our time, we're starting at 6460 units, and then it's going to go down each year. Okay? All right. So the next one is about income and year. And so I want to have you try those right there. So try that. That would be like you're in debt. Okay, so, well, hey, you know, it could be that you, at the beginning of this time frame, maybe you're in college, and that's your monthly debt, you know, and until you get a job. And plus, I put 4.22 units. I don't know if this is in thousands of dollars or in hundreds of dollars or what. Yes. Okay, so our slope for every year increase, the predicted income goes up 4.22 units, whatever it is. All right, and then interpret the y-intercept. When the year is 0, whatever time we're starting at, the predicted income is negative $8,300.58, I guess. We don't know the units, but again, and it often does not make sense. Okay. So you need to know those phrases. let's now do the next page. Okay? You want to hear your songs one more time? We have got temperature and ice cream sales. So the first question is, what is the explanatory variable here? Okay, so you think the temperature is directing the ice cream sales? Okay, so what's the explanatory variable? All right, then we're going to write it in here that the temperature is the explanatory variable. That is in degrees Celsius, by the way. And the response then is the ice cream sales. All right, so I want you to, we're going to write the equation of the least squares regression line in context here in a moment, but what do I need to do to be able to do that? Yep, we're going to use our calculator to get the linear regression. Okay, so you've done this before. So do you know where to go to get that? Okay, here's the steps. You're going to go and put these into stat edit into your calculator. You're going, yep, so write this down. Stat edit. You're going to put your x variable into list 1, which is temperature, and your y variable into list 2, which is ice cream sales. So I want you to take a moment and put those values in now. Okay, so after your data is in there, we're going to now calculate the equation of the line. Okay, so in order to get the equation of the line, your steps are to go stat, calc, over to calc, and then number 4, which is linear regression. So here's how that looks on your calculator. I'm going to go stat, arrow to the calc. Number 4 is linear regression. And then you hit enter. Okay. Now you may or may not have the r value or the r squared value. The r or the r squared showing up. We're going to address those another day. Okay, so you should have the numbers for your slope is 30.09. We're going to just round to 2 decimals. So slope is 30.09. And what's the y-intercept? Oh, I got negative 159.47. Okay. If yours is a little off, then that means you just have your numbers in your calculator a little off. Okay, so yes. Okay. Shh, shh, shh. I want you to write the equation of the least squares regression line in context. So our y variable was ice cream sales. So we are going to write ice cream sales. And here's the other thing. You have to put the prediction hat on there or it is wrong. Because the equation of the line predicts what happens. It is not what actually happens. It's an important idea. This line predicts what's happening. It's not the reality. And so then we can put our slope is 30.09, and then our x variable was the temperature in degrees Celsius, and then minus 159.47. Okay, so then now here we have our other 2 items, interpret the slope and interpret the y-intercept. Okay, so we've just done that. So I want you to, in context, interpret the slope and so on. So interpret the slope. For every 1 increase in the x, so I put for every 1 degree Celsius increase, or you could say for every 1 increase in the temperature, for every 1 increase in the x, the predicted y no, I put it in context. The predicted ice cream sales does what? No, it goes up 30.09 units, whatever that is. I guess these are probably dollars or thousands of dollars or something. What does it say? It doesn't say. So I'm just going to put units. Okay? All right, now interpret the y-intercept. It happens when the what? When the what? X is 0. And in this case, when's the x 0? When the temperature is 0. So if it's 0 degrees Celsius outside, the predicted sales is what? It's negative $159.47 or whatever units. It's not, that's a negative value. So, you know how the y-intercept often does not make sense that you're making negative $159 or whatever. Okay? All right. Now, we're going to graph this. So, up here, I'm going to be very specific on what I want. I want you to label the axes first. Okay? So, what is the x-axis going to be? Temperature, okay? Temperature in degrees Celsius. What is the y-axis? What's the y-axis? Ice cream sales. Okay, so write those things on here. Now, I'm going to have you look at these items in your calculator, and you're going to kind of like estimate where they go on this graph. I'm not going to make you count and actually put all the little dots exactly where they're supposed to go. You're going to make them look like what your calculator looks like. Okay? So let's look at how the calculator looks. Okay, so you ready? I want you to put calculator steps down here at the bottom of your paper so that tomorrow when you do this, you have the steps written out. It's different. So write our calculator steps. Okay? First, we need to turn a stat plot on so that we can see the points. So turn stat plot on. And that is done at second y equals. Okay? So let's do that now. So I want you to push second y equals. And do you see how there's all these plot 1, plot 2, plot 3, all those different things? I want you to hit enter and go into that first plot. And it says off. It might say on. I don't know. So I want you to hit on. Okay? Now you might want to make sure that your X list is list 1 and your Y list is list 2. Mine's not. So I got to fix it. My X list is L4. So here's how simple it is to fix it. I'm down here with my blinking cursor on the X list, and I want list 1 instead. I want to push the second button and number 1, and it turns the X list into L1. I want to turn the Y list into L2 because that's where I put my Y data. So I hit second 2. There we go. Now you might already have that, so you're ready to go. Okay, next, the calculator will do a nice, beautiful window for you. It will be all set if you press Zoom Stat, which is Zoom 9, Zoom number 9. Okay, so let's look at how that goes. Zoom 9, and it should look like that. Okay, so if you do have an error, then I need to help you with that. Okay, why is this here? Because I was looking for one, and I didn't have enough for everybody. Okay, the last thing that I want us to do, I want you to make sure that your line is in there. Make sure, and here's how you get that in there. Make sure your line is in y equals. So that means I need to come up here to y equals and type in my equation of the line, which was, I believe, 30.09x minus 150, what is it, 7 or 9 or what? 159.47. So then, look at it again, zoom 9, and look at that nice, beautiful line going right through there. Okay? Let's go. Get your line in there. So I just went to y equals, and I typed my equation of the line in y equals, and then I looked at it. Okay? It's the equation of the line that you wrote down there on the previous problem. Okay, so now we're going to come up here and graph it. So I do want to point out that your y-intercept is negative 159. Do you have enough space on this graph to show negative 159? No. So I'm going to just kind of like pretend. I'm going to put some little squiggle marks, and I'm going to draw a line that looks like my equation of the line. So you draw a line. Now, I want the dots that you have to look like the dots on here. Okay, I wonder if I can pull this thing over. Yeah, cool. Okay, so I want these dots. See, I've got one that's down here below it, and then another one that's a little below it, and then here and here, and then these two. That one looks like it's on it, and then a little below it. Here, here, here. Okay, so do you see, I am making my dots go around that line just like they do. Okay, so I'm approximating my lines just like my calculator. See, I'm making all of my dots look just like my picture. Okay, that's the last step. Okay, so again, today in summary, interpret the slope, interpret the y-intercept, writing the equation, putting into the calculator stat plot, and you have your steps written here for when we do work tomorrow. Make sure you put your calculators up, please.